Hello everybody. So again, this is Dr. Sergey Sargasov, and I want to give us a comprehensive video of conic sections, and specifically examples mathematically of how we could look at the general form, and from it conclude what the conic section is and what the graph of it looks like. So let me do that instead of talking about the definitions and the examples, because I've done that in other videos. But again, just a quick reminder, conic section, you see the cones here? So a cone is actually mathematically kind of this, see that? Let me kind of do a little in black here. You see that right there? So if you do that and then that's a cone, right everyone? Like, let me actually do it below a little bit. So a cone, like a conical cup where we can drink water from, but if you extended both directions infinitely forever, like that, you get what we mathematically call a cone, okay? And if you intersect a plane, like a sheet of paper, with the cone, as like let's say the blue, you see those planes with the kind of the orange or goldish cones, you will get a conic section. Now, it says here parabola, circle, ellipse, hyperbola, okay? But there are actually two others that I want to stress, okay? Two others that are possible. If you intersect actually the plane with the cone here, you can get two others, being a point and a straight line. Okay, I know those are more trivial, but at the same time, they're still conic sections, and so people almost always forget to mention them. Okay, so I want to also say, if you have a, let's do a cone, that, okay, I'm going to copy it and paste, do another example, but I'm going to basically draw a cone, okay, and it goes on forever. And if I take this cone, okay, let's do two examples because there's also what? There's also a point and a line. So if I do like an intersection this way, imagine this, like that, right? And it goes through this point, like that. That's a point, okay? Point is also a conic section. And if I do right along this edge here, you see that? If I do right along there, a plane, like that, let me kind of make it a little bigger. I just want to make sure you understand this is also possible. So I told you I'd just do mathematical, but I want to give you a little bit of theory also. And so, of course, I'm kind of a little conceptual as well. So, yeah, and that should be right there. That should be not bold. So that should be here, and then that goes behind it. So, okay, just the idea there, that's going to be a line, everyone. If you barely touch that kind of edge right there. So a line is going to be like that plane tangent to that, right here, you see this? To that, and also going to the center, but to that cone. Okay, anyway, so now let me show you what a general form of a conic section looks like. Okay, everyone? What it looks like usually would be a coefficient times power of x, x to the second power, x squared. So it's always, you never have anything outside of this. This is a kind of mathematical form of it. It's called general form of a conic section. If you see it written this way, okay? And then some x, some y, and some constant. Now, let me be clear here. Sometimes if you want to apply a revolution, let's say graphically to the some degrees, like let's say clockwise, counterclockwise, you could have a term, another term. Let me kind of give it a different color. Let's call it like a k, okay, xy, okay. And so I'm going to erase that because usually for the examples we see, they're a little bit easier. They will not have that, okay. So any math class, very rarely will you actually be doing kxy, okay, but you can have that. Okay? And you can play around with it. You'll see it's kind of cool. There's a few things that happen there. But if you do this, cx plus dy plus a constant e equals 0, okay? Equals 0, you can put the e on the right side, it'll be a number. Anyway, that actually, everyone, is the general form of any conic section. Right there, we just wrote mathematically, so general form. If you ever see general form. Okay, now let me do some examples and we'll graph them. we'll figure them out. We'll analyze them, and we'll see what they are. So let's just do mathematically. For example, this one, a. Let's try an example. X squared plus 2y squared. So you see ax squared plus by squared. Let's do plus, so minus a 6x, negative 6x, and maybe some kind of y, like a 4y, and maybe plus a constant 11 equals 0. Let's see, what in the world is this conic section? Is it looks like an ellipse to me. If I'm actually a little bit more experienced, if you maybe know already some things, you probably think this is an ellipse, right? I mean, some of you may know it a little bit, but it actually may not be an ellipse. Let me show you how cool this one is. It's the tricky. So anyway, the trick to doing these conic sections, you want to put them like more in like standard form versus general form. You would have to complete the square. Okay, so you would put first of all the x squared and the x terms together, and the y squared and y terms together. So put them kind of aligned with respect with each other, and you can get the number on the right side. Doesn't matter. Let's negative 11. Okay. Then we complete the square, everybody. And completing the square, let me kind of say, this is the wording. So if you need to look this up, if you're struggling with this, complete the square. Very important. This is how you do like parabolas, and actually that is a conic section, right? But parabolas in vertex form, if you study in algebra class, this is how you try to solve a quadratic equation. One way is completing the square. This is how you prove the quadratic formula. You have to complete the square. So let me show you what we do here. I'm not going to give you too much insight as to how to complete the square. That's another video. But completing the square, x squared minus 6x. I'm going gradual on this problem. Later on, I'll just go more quickly. Okay. So complete the square. What is this? X minus half of 6, right, is a 3. You square it. And if you do that again, it will be x squared and then minus 3 minus 6x, okay, if you multiply that out, and plus a 9, right? So take away the 9. There's no 9, right? There's no 9 right here, okay? And hopefully this lag, I'm having a little lag, is going to go away. Okay, so I'm going to try to be gradual and gentle for a moment because some videos have been cutting off and then I have to redo them. Just wait a little bit. Okay, let's see what happens here. So you have that. This actually right here, this underlined and that underlined, they're identical. They're equal. Okay, they look different, but they're equal to each other. The next one, you factor out a 2. So plus a 2, and then that's what? Y squared plus 4 over 2 is actually a 2. 2y. We're going to complete the square in a bit on this. Okay, so we did that. Now y'all see this is the same thing. We still have to complete the square on specifically that. Okay, so this, what we do is we say continue. We'll write this x minus 3 squared minus a 9. Let's keep it there for now. Plus a 2. Let's put brackets this time, and it's going to be y plus half of 2 is a 1, so squared, and take away that 1 squared, which is a 1. So you can check that this under the squiggly one and this squiggly one, they're equal. You can check that. This is completing the square. If you don't see it, you're a little frustrated. I'm telling you, you got to look up what does it mean to complete the square and how you do that. Okay, some of you are familiar with it. No problem, no question. Let's move on. Okay, so now equals negative 11. Now put the constants on the right side. Expand, simplify. Let's see what happens. X minus 3 squared minus a 9 plus a what? 2. So we're going to just simplify this a little bit, this expression, all this stuff. And minus a 2 equals negative 11. If anybody sees, the negative 11s will cancel, and you have, this is a very tricky one, okay? X minus 3 squared plus a 2y plus 1 squared equals actually 0. And the only way, note, okay? Only way this can happen, not using imaginary numbers, by the way, okay? We're talking about graphing and all that. This is real number line stuff, okay? Imaginary numbers, okay? We're not using them. So no squaring, getting a negative, okay? The only way to square something, get a 0, is squaring a 0, okay? Otherwise, it's going to be a positive number. If you think about a positive plus positive is not going to be equal to 0. So it has to be 0 and 0. So specifically, we have to have is x minus 3 is going to equal to 0, and at the same time 2y plus 1. I mean, x plus minus 3 squared is equal to 0, so x minus 3 is 0, and the y plus 1 then, right? Let's just kind of say it. Since 2, y plus 1 squared is equal to 0, this is going to be equal to 0. Let me put parentheses around this. And this equals 0. And so, basically, we have what? Let's go here. X equals 3, and y has to equal to specifically -1. And you know what that is, everybody, right? That's the point. That's a point. Graph it. That's all you have to do is 3 and -1. Cool, right? So that's an example of how you do a point. It's possible. You see that? Some people don't realize that it's possible. Okay. Let's do example B. Okay, you probably can see where I'm going to go with this one. Okay, and it's a little, again, delaying, so I'm trying to make sure it's not going to mess up. It's been cutting off a lot, and so this is like my 5th time doing a conic sections video, and I can't finish having a full one. So I'm trying really hard to like just being gentle with it. Okay. All right, so I'm going to give it a pause, and I'm about to write another everyone example. So let's try this one here. Let's do. I'm actually gonna put like numbers. So how about 0x squared? Okay, so instead of me just not having it, usually you would not have it. I'll put 0x squared plus 0y squared plus let's do 2x plus a 3y and plus a 6 equals 0. Okay, and somebody will probably see what this is. It's just what 2x plus 3y equals 6 equals -6, right? And you know what this is, everyone? This is a line. You could even find, for example, so it's a line. You can already say it's a line, right? It's actually, if you solve for it, look, y is equal to what? -2 over 3x, and then what? Minus a 2, okay? So slope m is -2/3. That's the rise over run. I'm not here to teach lines at this point. And the y-intercept is 0 for x and -2 for y. Y'all see that -2 right there. And so that b, right? B is -2 right there. So we have, and also you can do like x-intercept. It will be, if you check it out, it's going to be a -2 comma 0. See? I mean -3 comma 0, because 2 times -3 is a -6, and 3 times a -2, oops, is a -6. All right. So anyway, let me quickly draw a picture of this. Oh, and I forgot. I could label it, the picture. What is it? Like, let's actually, oops. Let's do a picture, so I'm not just making stuff up here. When you graph it, like let's say we're actually trying to graph all this, you would have what? What does it mean, the point 3 and -1? You actually go on the rectangular coordinate system. This is y-axis here, x-axis here. What does that mean? You actually go 1, 2, 3 to the right, and then -1, so 1 down. So that's our point. Okay. 3, -1. Let me make it neater. So 3, -1. Okay, just so you know that, yeah, that's something you could actually graph also. Okay, now this one is a line. Again, very easy, nothing new for us. This is kind of, some people don't teach this because it's already so, in quotation marks, trivial. But I think sometimes we forget things like this, so it's important to look at them. Okay, so this is going to be c-intercept -2, and then down 2, run 3. I'm looking at the, and so that's the idea. There's a line there. You can check it out, why I'm doing that. Kind of maybe review it a little bit more. But here is our line. Okay. Yep, and it's going to those points, and it's a slope -2/3. Okay. Now, let's go on while it's still working, while it's still recording. Example C, the third example we're going to do. And hopefully we get to the last ones. That's the goal. That's the more important ones. So C, let's try this one. X squared. Let's do plus an 8y. Oh, we don't. Let me just do plus. You know how I used to do the. How about 0y squared? So no y squared, and then minus a 4x, and then plus an 8y. Okay, plus a 28 equals 0. Let's say we have this. Okay, so when we have this, what we're going to do is we're going to, complete the square, all that. So x squared, that's delaying again, x squared minus, I'm trying to be really careful here so it doesn't shut off on me, 4x Let me give it a little pause. So I'm trying to make sure it's all working. Okay, so x squared, then minus 4x. I think part of it is trying to sync to other platforms and device locations and all that, and I probably maybe should even close the Wi-Fi, whatever. But anyway, so x squared minus 4x plus 8y plus 28, you can just keep it there for now, equals 0. Now, what do? You complete the square. X minus a 2, I'm doing right this on this right here, right? Squared, and take away that 2 squared is negative 2 squared, doesn't matter, it's 4, so minus a 4. Again, everyone, check to make sure, hopefully you can all see that these are equal to one another, okay? But this is completing the square is what it's called. And then, you know, plus an 8y plus a 28 equals 0. Okay, and I'm not going to prove the parabola anymore. We've done this in many other videos, the equation, all that. But let me show you what happens here. So you get x minus 2 squared plus 8y, and then what? Plus 24 equals 0. Get rid of the x squared stuff to the right and factor out the 8. So 8y plus what? 3 is equal to negative x minus 2 squared. You see that, everyone? And y plus 3. And I'm going a little quicker on the arithmetic and computation than maybe you like, but go ahead and check it. Pause the video, check it on your own, and you'll get a negative 1 over 8 x minus 2 squared. Now, the formula that I've actually taught in some other lectures already is this. If you have, this is actually a vertical, so vertical, because y equals x squared, you would have y equals 1 over 4p. Let me put, you know, x minus h squared plus a k. Sometimes people put it there. Let me actually move the y and put minus a k. This is my favorite way of looking at it. Y minus k and equals that. So vertex h comma k, up, down, okay, up, down. So up is if p is positive, down if it's negative, but it's a vertical, up, down, right? Parabola. Oh, and this is a parabola, everyone, by the way. So I forgot to mention that. That's the most important part, one of the biggest things here, right? So this is a parabola. Okay, you'll see what happens. Again, I'm not going to explain why the shape is what it is at this point, but, and then, oh, I didn't mention the vertical is that, and horizontal, that's if you had x equals y squared, everybody. Okay, so let me show you an example of horizontal. Not an example, but just a formula. What if it was, you know, what if you had an x, but you had a y squared, right? So no x squared. Or, again, it's pausing on me here, slow motion. All right, y'all look at that, kind of look at what's going on. I'm trying to make sure that you know, it doesn't just shut off on me. Okay, so horizontal, horizontal, trying to write slowly. That's when you have x minus the h. H is still for the x, okay? Is equal to 1 over 4p times y minus k squared, and that's going to be vertex again is hk. It's going to be right, left. So right if p is positive, and left. Let me make it a little neater here. Left if p is negative. And by right up down, I mean, like, let's say down like this, and let's say left like this. Okay, but parabola, remember? And so one thing I want to mention, what is p? P, and this is like focus, and this is directrix. Okay, you guys may have forgotten what focus directrix are. I'll show you just at least what they are. And directrix, focus is that point it's focused around, and like if let's say you have parallel rays coming at the parabola, like a parabolic mirror, they'll be focused in that spot, reflect and focus there. And the directrix is kind of the how it's stemming from there. So directrix and vertex and focus are, you know, all parabola. What's the definition? I'll say it here right now, just verbally. The definition of parabola are all points that are equidistant from the focus and the directrix. Okay, so just remember that. Right? So P is distance. From vertex to focus and from vertex to directrix. They're both equal, okay? Directrix. And well, distance, I'm just going to say it so we don't confuse this. Distance. So from vertex to directrix. Yeah, so anyway, let's graph ours. You see that one right there? Let's take it again down here. Okay, I'm gonna mess around with this. I wish there's a little bit the computer. Maybe this computer is getting a little bit old too. Okay, because I've been struggling. Even like the network being kind of really well going, or like there's like processing like 0%. It's still lagging. I'm struggling figuring out what the issue is. Anyway, so vertex. What's the vertex, everybody? Let's just kind of go at it. It's a 2x minus 2 comma, and y minus a negative 3, right? It's y plus a 3. Okay, p. Remember, what is p? It's a negative, right? Do y'all remember how 1 over 4p is that number right there? So 1 over 4, so 4p is a negative 8, right? P is a negative 2. Now, some people just say p is a 2. But basically, this is going to be down, okay? And just think about p as being a 2. Doesn't really matter. You know, p, like the distance itself is 2, okay? So let me actually say, like, right here, the way that we did it, the absolute value of it, like, you know, if you have a negative 2, the absolute value of p is the distance, right? And so we do as now, we can graph it, right? So let me show you how to graph it. It's going up, right? Or down. Sorry, down. We just said it's down. And the way you would graph it, let me make a neat one. You have vertex 2, negative 3. That's a very important point. Basically, that's the core point, 2, negative 3, right? You have p is a 2. So you go down 2 and up 2, or, you know, p is negative 2. But so you have go down 2, see that? Pump. There's our, so this is focus. This is vertex. Up 2, this is going to be the line right here. Actually, y equal what, right? Y'all see that? It's the line y equals negative 1. Make it a little neater here. So that's the directrix. It's a horizontal line here, directrix. Yeah. Y equals negative 1. And so the vertex, you know, we have those points. And what happens is you're going around the vertex. So basically, let's say we have, for example, here, let me see, focus. So like this, like points like this. This is going to be our parabola. That's how you think of it. Let me make it a little neater here. That's how parabola will look, okay? And again, what it means, the focus directrix, all this, and the definition is that you see, for example, I try this point here just so we could understand it. You see, everyone, this point right here? So you see how that's, or let's say like a point right, I'm trying to get a good point. Right here, you see that? So you see how it's a 4 and a 3? And you know how that distance is 5? And this distance is also 5. So let me explain one more time just so you understand. This distance is 5, and that distance better be 5 as well. Okay, so when they're equal, that's what it means to be a parabola. Okay, it's when all points are equidistant. Oh, from the focus, sorry, not the vertex. So basically, from here it would have been. So it's a little bit off, right? But if you do that and maybe this, from focus, the points are equidistant. I mean, sorry, from any point in the parabola, these points, they're equal distance from the focus and the directrix. Okay, so directrix is perpendicular kind of to that directrix, to this point. Okay, that's the idea of so for example, like you see this, let's say we go from focus here, that distance better equal to that distance right there. Okay, and it looks a little bit off, but that's the idea, everyone. All right, that's how parabola definition, one of the definitions is. It's kind of tricky, right? All right, now let's go on and do another example, example D. Okay, while this is still working. That's hopefully it still does. So D, it's lagging again, so let me kind of just wait a little bit. I'm really being cautious because I'm tired of redoing these videos. So let's do this. D. Example D. Let's try this one. You'll see what this one's going to be. This is probably easier actually, but x squared. Let's do maybe plus a y squared. Plus a 4x minus a 10y plus 20 equals 0. What shape is this? And why is it different, right? It has an x squared and a y squared, right? This is just like that example A maybe, but what? But maybe something else will happen here. It's probably not a point. So let's see what happens. If you do this, let's go a little faster here. So x squared plus 4x is x plus 2 squared, and take away 2 squared is a 4. Okay. Then let's do y. The y step is y minus a 5. You see that? Squared. Take away 25. If you're confused about this stuff, again, everyone, just really study completing the square. It's not that bad when you know it. Okay? And plus a 20 equals 0. It's just not the goal of this presentation here specifically. Okay. And if you simplify that a little bit more, you see what happens? It's this plus y minus a 5 squared. And that's equal to, if you add it all on the right side, subtract the 20, you'll get a 9. Okay. Now, standard form of a circle. This is a circle, everybody. Circle. X minus h squared plus y minus k squared is equal to the radius squared. Okay. And so remember, circle is all points at equal distance from the center, and that distance being the radius, right? So what's the center here? The center, let's make sure it doesn't, again, mess up again. So let me slow down. Yeah, I'm going to have to use other computers next soon. Okay. So the center is h comma k, right? And what's the radius? Radius is r. Okay. So for us, the center is negative 2 comma 5. Okay. And the radius is square root of 9 is 3. Y'all see that? And let's graph it. It's pretty easy to graph now, right? Let's do a little one of these. And then what is it? Negative 2, 5. So we go left. We go left 1, 2, and what is it? Up 5. 1, 2, 3, 4, 5. That's that. And you see how it's 3 radius. If I do a shape, I'm kind of learning how to do this. Let's see. If I do that here, it should give me a circle radius 3. It's kind of cool. You see that? There it is. So that's radius 3, circle centered at negative 2, 5. And that's the idea. That's the shape. And you know what that actually means? If you do any xy, any point x, y, the x and y being related by this right here, this is kind of in general form of the conic section here. Like, you know, you put a y in whatever, the x has to be, you know, 2 possible values, whatever, or it can't be anything. Anyway, so whatever points, those are right here the points. They have to be these points. Can't be anything else besides those things on the circle. Okay? Really cool, right? That's what graphing is about. If you have some kind of relation between x and y, every possibility, the x with the y, that possibility, if you graph it, you get that shape. That circle is every possibility you can get. Okay? And it has to do with that distance formula. Okay? Basically, we're saying the distance from the center to the point, any point on the circle, is equal to 3 here, the radius. Okay. Let's go ahead and try another example. Example E, and I'm trying to be patient here with it syncing. Okay. Let's do example E. I think that was D, so let's do E. E, I'm going to try another one. We don't have too many to go, right? So let's see. 16x squared. Let's try plus a 25y squared plus 64x minus, let's do like 200y plus 64 equals 0. What is this shape? That's kind of weird. All right, let's see. It looks kind of messy too. Let's see. What we can do is factor out the 16 of the x squared and x terms. So 16x squared plus 4x, right? Check that out. I'll give you 64x. And then plus a 25 y squared minus an 8, right? 8y equals negative 64. Okay, right? Be careful there. Now what happens? Complete the square. 16 times x plus 2 squared minus a 4, and then plus, let's do 25, and this is what? Y minus a 4, half the 8, 4 squared, and take away the 4 squared is 16, okay? And that's equal to negative 64. All right, now, let's be careful here. We get 16 x plus 2 squared minus 64. I'm just distributing everything out, plus a 25, what is that? Y minus 4 squared minus a what? 200? Yep, no, it's like 400. 400? Yeah, 400. Okay. Right, 16 times 25, 400. Yep, equals negative 64. Gradual, it's again, I'm delaying. So let me wait a little bit. Okay, and then you see the 64s will cancel. So we have 16 x plus 2 squared plus 25 y minus 4 squared equals 2, and if you cancel all that, you'll get 400 on the right side. Now, what we do, this is actually an ellipse, everybody, and when you do that, you have to have a 1 on the right. If you divide by 400 both sides, let's just divide by 400, divide by 400, divide by 400, everything. That's how you get a 1 on the right. So 1 is equal to, and what you do here, if you actually have, you'll have a 25 at the bottom. So if you do 16 over 400, you can simplify it to 1 over 25. Okay. And then, of course, you have x plus 2 squared there, plus a what? Y minus 4 squared. If you check that out, it's going to be 16 at the bottom. Okay. And so you get that. Okay. Now, this is an ellipse, okay, everyone? And let me tell you how ellipses work. Ellipse looks like this. X minus h squared over an a squared. Let me make it 2 neater. Over a number a squared plus a y minus k squared over b squared, okay, equals to 1. And the a will be horizontal and b will be the vertical, basically. Also, there's something called c. C squared is equal to the kind of the positive difference between a squared minus b squared. So that's the value, okay? And what that is let's do actually with ours, and also the center is so h comma k, and whatever you see. So there are 2 foci, focus 1, focus 2. So 2 foci, okay, and it depends on. Let me just say that are little c, not big C. That is a big C, okay. That's a capital C. But that little c, okay, so that right there, little c, are c away from center. And it goes up and down or left and right, depending on if it's vertical or horizontal. If A is greater than B, it's horizontal ellipse. So like this. Okay, and you have center, you have foci. So you see that center foci, and then that's it. And then this is called the big thing, the horizontal right there. See this, everybody? That's called, I'm going to wait a little bit again, but that's called major axis. And this right there is called minor axis. Okay, so the small one is minor, the big one is major. And let me wait again because it's again delaying. Okay, that's good. So again, everyone, remember, this is our A, this is our B. This right here to the focus is C, F1, F2. I see the left one too. And let me make it a little bigger so you can see a little bit what's going on. I know it's kind of hard to see. And then the 2A, if you ever hear these terms, okay, this is called the major axis. And what do you think that vertical one here? This is going to be the minor, 2B, right? It's equal to length, that's 2B axis. And so again, this is if it's horizontal. Okay, everyone? Now, if it's vertical, it's very similar. It's just going to be flipped. So that's when B is greater than A. And then it's vertical. Okay, same thing going on, but the foci are going to go up and down. So it's going to look like that. Okay, yep. And there's a center, focus, focus, and so on and so forth. Okay, that's the idea. All right. All right. So what's ours? Let's check ours out. RA, what's the square root of 25? It's a 5. B is a 4 here. You see this? So here, so you're going to get A as 5. B is 4, right? C is going to be, what's that? Square root of 9? It's going to be 3. Center is a negative 2 comma 4. Y'all see that? X plus 2, so negative 2 comma 4. So let's do that. Center, negative 2 comma 4. I'm actually doing our example. A was equal to 5. B is equal to 4. So you see this is going to be what? Horizontal. Okay. And we have C. Remember, C is equal to the absolute value of C squared. I mean, did I put C squared? Absolute value of A squared minus B squared. And that's going to be absolute value of 9, if you check that out. So C is equal to, C squared is 9. C is equal to 3. Let me show you. Did I put C squared there? Yeah, I did. Okay. So now, what we do is we graph it. Okay, everyone? Let's graph the ellipse. Okay, let's just check it out. The center was, again, what was it? Negative 2 comma 4. So go left 2 and up 4. Here we are. That's center. Okay. What was A? A was 5, and that's horizontal. It's delaying again, so 1 second. Okay. A, left and right from there. Three to right, left and right through. That's focus, focus 1, focus 2. You can actually call this focus 2. Let's go left to right. Focus 1 and center. A was 5, so go 2 more. Okay. And left right here. And up 4. B was 4 from the center. So right there. And right there. You see that? And you see that right there? That's going to be ellipse. It's going to go through those points right there. Well, ellipse. It's like an elongated circle. And actually, if you think about it, if I have A equals to B, you will, if you simplify, you'll get an equation of a circle back. If A equals B. Okay? But that's our ellipse right there. Cool, right? Okay, and let's do the last example while this is still working. Okay, while we haven't been cut off and the video hasn't just cut off on us, and that's it. Okay, so let me be really cautious with this. We've done already quite a bit. Let's do our example. What was that? E. Let's call it F now. Okay. So 6 conic sections, as y'all remember, I told you about. So this one you can probably know what it is. It probably will be a hyperbola. All right. And I'm going to be a good example here. All right. So hyperbola, let's try this example right over here. Okay. Negative 9 x squared. I'm going to give you a general form of a conic section, this one, plus a 16 y squared plus a 36x, and let's do plus a 32y, and minus a 164. So you see it still looks like a general form of a conic section. And let's work with this now. Okay, I'm going to speed up a little bit maybe now. Take away a negative 9, right? And what happens? That's going to be x minus actually a 4. Careful there, right? Squared. And check that again. That's going to be this stuff right here. Okay. And what is the next stuff? That's plus 16. And y squared and y, that's just a y squared plus a 2y, right? Okay. So that's that. And equals 164. 164. Delaying a little bit again. Okay, I'm going to wait. So, what we can do is, we can, oops, that's, I messed up there, sorry. That's incorrect, glad we looked at that now. It's x squared minus 4x, is what I meant, right? That's what I was trying to do, oops. Anyway, and so we have negative 9 x minus, complete the square on that, 2 squared minus a 4, 2 squared is a 4, and then plus a 16, and to complete the square on the y stuff, it's y plus half of 2 is a 1, and then take away the 1 squared, okay? And then that's equal to 164. Let's see what happens here, okay, everyone? So when we do this, we have what? We have, let's check it out, negative 9 of the x minus 2 squared plus a 36, okay? And then what is that? Plus a 16, y plus 1 squared, okay, minus a 16, okay, and that's equal to 164. Why I'm pausing to think a little bit here, let me tell you something. A lot of times you would have been given this, actually. Let me show you. You could have been also given, most of the time you would have been given a problem like this instead, where they just flip the sign of everything, because they like sometimes having a positive x squared, okay? So positive 9x squared, and this. I'm actually, you know what, I'm going to take that right there. Oh, and that's, oops, we're messing it up. So minus a 32y and plus a 164 equals 0. Usually it's written this way instead of the second one, the one we actually started with, okay? And you would still get the same thing, of course, because it's equal to the same thing. But let me show you. So there you have, let me pause a little bit again. Let's see what happens. Okay, so now we do is this, ready? We have negative 9 x minus 2 squared plus a 16, right? Y plus 1 squared is equal to, and if you put those together, that's actually 144 if you see that, right? 164 minus that 20 right there. Divide everything by 144 because we need a 1 on the right side, okay? You get negative x minus 2 squared over actually a 16, okay? And plus y plus 1 squared over a 9, check it out, equals to a 1. Okay, everyone, this is a hyperbola. This would actually be a vertical hyperbola, okay? So hyperbola. Let me do horizontal first. So if you have x minus h squared positive, because we have a negative, right, over a squared plus a y minus k squared over b squared equals 1, okay? What you do is, this is going to be horizontal. Okay, so I'm giving you a little theory kind of behind, not just examples like I was hoping for, but so a little bit more. But that, hopefully this helps you, okay? And this is what I mean by horizontal hyperbola. What I would think of it as is this, everyone. Do not think of it as a parabola left, parabola right, okay? It has nothing to do with parabola. More so, think of it as take an ellipse, cut it, and kind of flip it around, but this goes on forever along the asymptotes. That's forever, this hyperbola. It's going to lie between. Okay, everybody, so the video just got cut. Everything dropped and closed, unfortunately, but I will continue from here, and let's see if I can kind of crop these together. It's going to be tough, but we'll do it, maybe. All right, so continuing from where we left off, I was saying that you have a hyperbola, horizontal. These are asymptotes, and you see what happens here? Right here, let me show you. Okay, this is going to be like, okay, I'll show you. There's a center right there, right? It's already lagging. Center. Right there, that little distance. Okay, that's going to be, that's going to be our A. Okay, everyone? Right there, little A. This is going to be our little B. B is going to be where? It's going to be where you have a little, right there, that little box that makes those horizontal asymptotes happen, okay? is going to be B. And this right here, from there to the focus, let's say I have a focus, that's going to be C. Little c is always to the focus. I know it's hard to tell the picture. I will not draw the C. I will erase this the center, because the center, of course, you understand. And I'll put a little C right there on the length between, this is focus. Focus 2 and focus 1. And this is going to be right here, C. Okay, so C is the distance from focus. A is like a 2A is that, 2B is this. Okay. Anyway, it's a little tricky to see that, so I just want to show you at least something. This is not the goal of this video. I'm not proving to you, as I used to before, how to derive the equation for hyperbola. Okay, but that's horizontal, and we actually have a vertical one. Okay. Oh, and sorry, I should put a minus here. The whole point is there's a minus. Okay, and if you take the same thing, everybody, the same equation, okay, but you have a negative on the x squared, okay, and a positive on the y squared, that will be, so I'm going to put a minus here and a plus here, then it will be vertical. Okay? Be vertical, and that's our example. So it will look like this and that. I'm trying to show you a little bit what's going on here. Okay, those are the slant asymptotes. Okay, you have right here the center. This is going to be A. Okay, A. You have this point and this point. Okay, A. Okay, now if you go B horizontally, you get those kind of locations for where you would have to draw these slant asymptotes. You see slant asymptotes pass through the diagonals. So this is 2A, and this is right here 2B. Okay, everyone? And so that's the idea. And what is C? C is from, you know what, I'm going to erase this right here now. Okay, kind of probably do that. Let me kind of, it's lagging again. So let me erase the A. Because we know it's already A since that's the 2A on the right there, right? Not even letting me record this 3 minutes, alright, but let's see. So I'm going to erase A. Oh, where's delete? Delete A. Delete A. I'm going to delete this. Delete this. Okay. And so what I was going to say is, what is C? Okay, it's lagging again. What is C? C is, okay, again, this is so tough to do when the computer's lagging. Okay. C is that distance to the focus, everyone. So called focus. And there's focus 1, focus 2, there's of course one above as well. And that's going to be length C. Okay. So what is C? C actually you see is longer than little a and little b. Okay. So C squared will actually be a squared plus b squared. No need for absolute value. And that's finally, and that's distances to foci from center. Okay. That's the idea. That's what distance the C is. Okay, so let's now go back to our example and let's look. A, can y'all see what A is? What's the square root of 16? It's a 4, right? What's the center? It's a 2 comma negative 1. You see that right there? We're talking about right here. Our equation. And so we have center 2, negative 1. I'm going slowly because again it's delaying. Okay. So 2, negative 1. I really want to just finish this and connect this video with the last one. I'm going to try to crop them and combine them somehow. Okay, it's not going to be easy. It takes a long time to do that. So I think I said 2, negative 1. I'm going to say center. Okay, so the center is 2, negative 1. Okay, I can't even delete the C. So slow. All right. I'm going to wait. I'm really going to be patient here. Maybe I should pause the syncing. I don't know. Let's see how to. Well, anyway. Now, center, that's the idea, is this. Now, what is A? A is 4 square root of 16, and B was 3 square root of 9, right? Let's look above. See, A is square root of 16, B is square root of 9. And what's C? If you add 16 and 9 and square root it, C is equal to 5, right? Square root of 4 squared plus 3 squared is equal to 25, so square root of 25 is 5, okay? And so this is, again, what? This is actually, is this a vertical or horizontal? It's vertical, because it's you have a negative x squared plus y squared, right? So we have vertical. Okay, and we're going to do this. We're going to draw our last graph. This is the only other one we had left to do, conic section. Okay, what is our center? 2, negative 1. All right, so we have 2 and down 1. Okay, A was a what? A 4. So go right 1, 2, 3, 4. Left 1, 2, 3, 4. Okay, let me show you how this is done. Actually, see, that's an A, and that's A. So I'm going to erase this, but I want to make sure you can see that. Let's go up and down 3. B is 3, right? There's down 3. There's up 3. C was 5. So now we're going vertical, right? So go up and down, not left and right, but up and down 5. So that's going to be the first. Okay. That's going to be go down 5 from the center. It's lagging already. It's going to be the second focus. Okay. Now you see this right here? Let's draw a little box around this A and B stuff. Left 4 and right 4, up, down 3. Okay. Because the slant asymptotes are going to be the diagonals of those corners, through those corners. Okay. See these corners? Let me show you. Let's draw a line. Let me do a thin one, very thin. Let me do like here, and let's do a little line now. So you see that, everyone? Like that. And let me do a little neater. Okay, nope. Okay, like that. And if I do another line, let's do like this and like that. See that? These are going to be called the slant asymptotes. Actually, the equation for them, if you think about it, is y minus, it's also the center. And if you do the point slope form, you can remember. Let me do that a little thicker here. So if you want to figure out, you can find the equation of these slant asymptotes. Let me call them slant asymptotes. Sometimes people just say asymptotes here for the hyperbola. And what you say is y minus a k is equal to plus or minus rise over run. Remember, this is a b, and the horizontal is a a. Remember that? So you do b over a, and then times x minus the h. You can check that out. Those lines are going to be exactly those orange ones I drew. Okay, that equation for line. You know, if you're familiar with lines, you would understand that. And so look, this is a vertical hyperbola. Going, remember, so remember the a kind of gives you that where it is. So we would go. Let me wait a little bit. There's delay. I think. Let's see. We would do this. We'd start here, and we would approach the asymptotes. You go left, the same thing. You're approaching. So you see, it had nothing to do with a parabola. Even though it's like people say U-shape, whatever, this is not a parabola. It's more like an ellipse that's kind of torn apart, flipped around, and then it's, you know, like going in infinite directions along those asymptotes. So it's not really even an ellipse, right, at all, flipped or anything. But that's the idea, and then you go from here also similarly, like this. And there's curvature there, right? Like that. This is our hyperbola, everyone. And I'll make it a little neater. Let me kind of do it. Okay, everyone. That's it. Cool, right? There's our hyperbola. All right. And what I'm going to do is I'm going to basically stop the video here, and let's see if I can connect these two. This last second part of just hyperbola and the one I was doing that had everything in it. All the other ones. Okay. Basically, look at all what we did before. Okay. All right. Thanks for being here, everybody. and I hope you have a good remainder of your study time.